we continue with our identities now. So basically the most important identity that we need to understand comes just from a simple problem here. So take this as the x or y plane. So in that manner, where that is our triangle which is there, we have got the y-axis and the x-axis. So take the side which is parallel to the y-axis as y, the side parallel to the x-axis as x, and then this, the hypotenuse, take it as the resultant. Alright, take it as r, or you can give it any letter that you want. So using the Pythagoras theorem, notice that r is the hypotenuse, the longest side. So r squared is equal to y squared plus x squared. Can I also write as y squared plus x squared is equal to r squared? Really nothing has changed here. I've just transformed the parts of the equal sign. So I want to remain with a 1 there. So I'm going to divide everything by r squared. So what I'm having is y squared over r squared, which you can also write as y over r, and then I put a squared outside, and then x squared over r squared, which I can also write as x over r, and then I put a squared outside. R squared over r squared is a 1. Now say this is the angle. Let's say this is alpha, the angle. So if we talk about sine, so sine alpha is going to be equal to, we know that sine is opposite over hypotenuse. The opposite is y. The hypotenuse is r. So sine alpha is going to be y over r. And then cos alpha, we know that cos is adjacent over hypotenuse. The adjacent is x, hypotenuse is r. So that will be x over r. And then we're going to go here where we can see y over r. We're going to substitute our sine alpha. So that gives us sine alpha, and then we are squaring that. And then plus cos alpha, we're also squaring that, and that is equal to 1. So we can even expand removing the brackets. That gives us sine squared alpha plus cos squared alpha is equal to 1. Please, whenever you are removing these brackets, the squared doesn't go on the angle, it goes on the trig ratio. And when you are pressing on a calculator, don't write sine squared and then you put your angle. You need first to write your sine angle and then you put a squared outside. Otherwise, this won't give you the answer. Alright. So this is a very important trig identity that we need to get to understand and always go with all the identities that we are going to be talking about. Because basically the others are going to come just from that one. Okay, so let's go on. So that is the first trig identity. Sin, let me use x instead of alpha. Sin squared x plus cos squared x is equal to 1. This is the first trig identity which we have. Now, of course, we know that sec is the opposite of what? It's the opposite of cos. So sec x is the same as 1 over cos x. Okay, this we know. Now, we know that 1 is the same as what? We can replace where there is 1, we can put what we are having there. So where there is 1, we can put, okay, let me let it this in this form. If sec x is giving us 1 over cos x, that means if I square sec, it becomes sec squared x, then even the cos down is going to be squared. Alright. So sec squared x is the same as 1 over cos squared x. And then where there is 1, I'm going to put this because we know that 1 is the same as sin squared x plus cos squared x. And that is now divided by cos squared x. If we have got 1 plus 3 over 2, we can also write this as 1 over 2 plus 3 over 2. We simply split the 2. Okay. So we're going to split what we are having. So this is going to give us sin squared x over cos squared x, and then plus cos squared x over cos squared x. But we know that tan x is the same as sin x over cos x. So that means if we square the tan, even the sin is going to be squared, even the cos tan is going to be squared. So sin squared x over cos squared x gives us tan squared x, and then plus cos squared x over cos squared x, that is going to give us a 1. So that becomes the second trig identity. Sec squared x is equal to tan squared x plus 1. So that means if we are talking about tan squared x, then it becomes this 1 is going to go over the other side and is going to become negative. So then that is going to be equal to sec squared x minus 1. Alright, so that is what we get to understand. Let's talk about cosec also. So cosec, we can write it like that, or in some books you can see it written in that manner. So cosec, we know that is the opposite of sine. So if we square cosec, that means even the sign down is going to be squared. Again, let's replace on top where there's a 1, we put sine squared x plus cos squared x, and then divided by sine squared x. So that is going to give us sine squared x over sine squared x, and then plus cos squared x over sine squared x. So sine squared x over sine squared x is a 1. Cos over sin. So if we say sin over cos, this gives us tan. And we know that the opposite of tan is cot. So if we change, it starts with cos and then over sin, then what you are going to get is cot, because cot and tan, they are opposites of each other. So cos squared x over sin squared x gives us cot squared x. So this is telling us that cosec, that becomes the fourth identity. Cosec squared x is going to be equal to 1 plus cot squared x. Alright. So apart from this, we can also have other identities which are coming from compound angles. Let's say if you've been given cos A plus B. So when you've been given something in this form, what you get is you are going to get a cos, you get a first angle that you have, that is the A, and then get cos again. You get the second angle that you have, that is the B. And then what you do is for cos, you change the sign, which is, if it was positive, it now becomes negative. If it was negative, it becomes positive. And then you start with sin. Sin, you get the first angle, which is A, and then sin again, the second angle, which is B. So that would be the identity. So that means if we add a negative here, then it would have been a positive on there. Okay. Now from this, that means if we use another A here, that means everywhere where we can see a B, we are going to use an A. So A plus A gives us 2A. So that gives us cos 2A is going to be equal to cos. Now this will be cos A times cos A, which is cos squared A. And then minus, because we had a plus here, so it will be a minus here. Minus, this is sin A, which gives us sin squared A in that manner. But we know that sin squared A plus cos squared A is equal to 1. So I can simply make any of these a subdivision formula. Let me make sin the subdivision formula. So that means sin A is going to be equal to 1 minus, sin squared A is going to be 1 minus cos squared A. So this has come from this one. So where I can see sin squared A, I'm going to replace with that one. So what we are saying is cos 2A is equal to cos squared A minus, where there was sin squared A, I'm now putting 1 minus cos squared A in that way. So this gives cos squared A minus 1, and then plus, because if this minus goes to that minus, it changes to plus cos squared A. So this gives me cos squared. Cos squared can give us 2 cos squared A minus 1. So that is an identity. So that is telling us that cos 2A is the same as 2 cos squared a minus 1. So because I'm using, if we are using x, then everything would become x there in that way. So this means okay, so this is coming from cos 2a. So if I take a 1, this side becomes positive. So what I'll remain with here is 2 cos a, and that is going to be equal to cos 2a plus 1, because the 1 has gone and it has become positive. So I divide through by 2. Everything divided by 2. So that gives me cos a being equal to cos 2a plus 1 over 2. This is also over 2. Alright. So that is another identity which you can talk about. Cos, okay, there is a 2 which I have left out here. There was a 2 between. So actually what I've written, I think this gave us from just this point which is here, cos 2x is equal to 2 cos squared x minus 1. So what I'm doing is I'm taking this one the other side so that we remain with this. So 2 cos squared x is equal to cos 2x plus 1. So and then we divide by a 2. So that gives cos squared x is equal to cos 2x plus 1 over 2. I've divided by these 2. Okay. So this one is squared, not 2. That gives cos 2x plus 1 over 2. So there's a 2 that we can see properly there. Alright. So there are really a lot of these which we can look at. There are many. So again, we could have used sine. It's all this. It's still going to give us another identity which is different from what we have here. Now let's go to sine a plus b. So for sine a plus b, what you get is you get the sine, you get the first angle, and then you change, you go to cos, you get the second angle, and then you just get the sign which is there. If it is plus, you get plus. If it is minus, you get minus, and then you change, you start with cos, you get the first angle, and then now go to sine, you get the second angle. So that means if we use also a here, then everywhere you can see b, we are going to have a. So a plus a will give us sine 2a, and that is going to be sine a cos a sine a, sine a cos a, and then plus. Now multiplication is commutative. Whether I start with a sine or I start with a cos, it's going to be the same. So I can also start again with this one which is here, sine a, and then I write the cos a. Notice that this and this are the same, so I can add those, they are like them. So that will be sine 2a is going to sine a cos a plus sine a cos a will give me 2 sine a cos a. So if I was using x, that becomes another identity. So sine 2x is the same as 2 sine x cos x. So if I'm working with identities, I see this, I can replace with that. Alright. So what if we are having halves? So say we had let's say we have got cos 1 over 2 a plus 1 over 2 a. Remember we said when we are working with these identities, you are going to first get cos, you get the first angle which is 1 over 2a, and then get again cos, get the second angle which is still 1 over 2a, and then subtract, go to sine. So that will be sine, get the first angle which is 1 over 2a, and then again another sine, get the second angle which is 1 over 2a still. Now 1 over 2a plus 1 over 2a will give us a 1. like half plus half is 1. So that is where this is coming from. So that is telling us that cos A, this is simply cos A, which you can also say cos x is the same as, now this can be multiplied with that because they are the same. It's going to give cos squared 1 over 2 x. So I've changed, instead of using A, I'm now using x, and then minus sine squared 1 over 2 x, like that. Okay. So let's look at another thing. What if we are talking about sine? Okay, assuming you want to have sine, want to get the identity for sine 1 over 2a. Now using two numbers, you name just any two numbers which we can add for us to get half. What two numbers can we add for us to get half? It's 1 over 4 plus 1 over 4. A quarter plus a quarter gives you half. So we can say even cosine, same. So if we are talking about sine x over 4 plus x over 4, this is going to give us, we get the first number first. We first get sine, the first angle, which is x over 4, and then we change to cosine, we get the first angle, which is x over 4. For sine, we don't change anything, we just get the same sign. And then we are going to start with cos, we get the first angle, which is x over 4, and then sine, the second angle, which is still x over 4. But you know that x over 4 plus x over 4 is x over 2, which is the same as half x. So this is going to give us, we can add these because they are like terms, so that will give us 2 sine x over 4 cosine x over 4. Okay, same when if we were given, let's say, in terms of cos. So cos x over 4 plus x over 4. Now for this one, we first get cos the first angle, which is x over 4, and then again cos the second angle, which is same x over 4, and then we subtract. We go now to sine the first angle, which is x over 4, and then again sine the second angle, which is still x over 4. So we know that x over 4 plus x over 4 will give us x over 2. So cos x over 2 is the same as cos squared x over 4. So if we multiply cos and cos, it gives us cos squared. And then the angle, just get it the same way it is. We don't multiply the angles again. And then minus sine squared x over 4 in that manner. So that becomes an identity again. Alright. So this is how we go on with the identities, and a lot of them, and such a thing. Let's say we've been told to prove some identities. So say prove the following identities. And let's get the first one as sec x is equal to cos x plus sin x tan x. Now the aim of identity is you get a part which is looking a bit complicated and work with it. So you see that this is going to be the left hand side, this is going to be the right hand side. So we are going to start with the right hand side, which is looking a bit complicated, and we say is equal to cos x plus sin x and then tan x. What I want to do is make sure that what can be simplified is simplified. So we know that tan x can be written as sin x divided by cos x. So which we can also write as cos x plus sin x times sin x gives us sin squared x over cos x. Now if you've been given something in the form 1 over 2 plus, let's say, 3 over 4, just multiply these two, that gives you 4. Then multiply these two, that gives you positive 6. And then multiply the two denominators, that gives you 8. So that is how we work with fractions. So this is the same as cos over 1. So we're going to multiply the cos times the cos, which gives us cos squared x. And then 1 times the sin squared, which gives us sin squared x. And then in the denominator, 1 times cos, which gives us cos x. Now at this point, we know that sin squared x plus cos squared x, that one which is on top, is the same as 1. So that will be 1 over cos x. And you know that 1 over cos x is the same as sec x. So what you've just shown is left hand side is equal to right hand side. So hence shown. So we've seen that this is the same as the other part which we are given. Alright. Let's look at another one. What if they've given us 1 plus cos x divided by sin x, and then plus sin x divided by 1 plus cos x is equal to 2 cosec x. So again, the one which is looking a bit complicated in this case is the left hand side. So the left hand side, 1 plus cos x divided by sin x, and then plus sin x divided by 1 plus cos x. So the way we take this is we are also going to multiply these. We are going to multiply them. So what we are having is 1 plus cos x multiplied by another 1 plus cos x. So this gives us 1 times 1, which is a 1, 1 times cos x, which is cos x, and then cos x times 1, which is cos x, and then cos x times cos x, which is cos squared x. And then you know that we can add this, that will give us 1 plus 2 cos x, and then plus cos squared x. So we're going to substitute. So if we multiply this with this, that is what we are going to get. The 1 plus 2 cos x plus cos squared x. And then we're going to multiply this with that, which will give us sin squared x. And then divided by, the denominator will just multiply this and that, but will not expand them. We'll just write as sin x multiplied by 1 plus cos x in that manner. So we know that cos squared x plus sin squared x is going to give us a 1. So this will be 1 plus this 1, that is going to give us a 2. And then plus this one which is here, which is 2 cos x, and then divided by sin x 1 plus cos x. So we are going to bring this here. We can factorize on top. We can see we have got a 2 there and also there. So we're going to say 2 open brackets 1 plus cos x, and then divided by sin x 1 plus cos x. Notice that this is going to cancel out. So what we are going to have now is 2 divided by sin x, which I can also write as 2 multiplied by 1 over sin x. Okay. Now we know that 1 over sin x is cosec x. So we can see that we have shown. So we write hence shown or hence proven. Alright, let's look at another problem. We see what we are able to do. So another problem given, we've been given sec x plus tan x and then 1 minus sin x is equal to cos x. So even here we're going to work first with the left hand side, which is going to give us sec x plus tan x, and then 1 minus sin x. So at this point we can multiply. Of course I can write the reciprocal. Sec means 1 over cos x, and then plus tan means sin x over cos x, and then multiplying them with 1 minus sin x. So if I multiply this first part with that, what I'll just get is a 1 over cos x, and then this part with that, it will give me minus sin x over cos x, and then this times that, what I'm getting is just sin x over cos x, and then this times that, what I'll get is sin squared x over cos x. Notice that this and this is going to cancel, so remain with 1 over cos x minus sin squared x over cos x. Now if the denominator is the same, we can simply add what is on top. So let me take it there. So just say 1 minus sin squared x on top divided by, the denominator is the same, so just write cos x. But we know that 1 minus sin squared x is the same as cos squared x. From the first identity, sin squared x plus cos squared x is equal to 1. So if you take this sign the other side, what you're going to have is cos squared x is equal to 1 minus sin squared x. So where there is this, we can put that. And cos squared x over cos x, okay, there is no squared here, it's just cos x, is going to give us cos x, which we can see there, hence shown. Alright, now let me talk about one other identity which I didn't talk about, the tan. So what of if you've been given tan a plus b? How do you work out this one? Of course we know that tan a plus b can also be written as sin a plus b divided by cosine a plus b. So what I'm going to do is I'm going to expand the sin a plus b. Of course we've just looked at the expansion. This is sin a cos b plus cos a sin b, and then divided by, now we look at the cos down, that will be cos a cos b, and then minus tan a tan b, oh sorry, not tan, sin a sin b. Okay, now our aim here is to make this to be a 1. And how do we make a 1 from that? So the only way that we can get a 1 there is to divide it by itself. So we're going to divide everything by cos a cos b. So we're going to have sin a cos b divided by cos a cos b, and then we write the second portion, which is there, the cos a sin b. We also divide it by the same thing, which is cos a cos b, and then we are going to go down, so that to be divide, we write this and then divide by itself, cos a cos b divided by cos a cos b, and then plus, we are going to also write this one, sorry, it's not even plus, it's a minus there, minus sin a sin b, and then we are also dividing it by the cos a cos b. Now notice what can cancel out here. Cos B and cos B can cancel. Cos A and cos A can cancel. But here nothing can cancel. All we can pair is we pair those which we have got A's alone and those which have got B's alone in that manner. And then this is going to give us a 1 because we are dividing by itself. So then that is going to give us, here what we've remained is sin A over cos A. Sin over cos is tan. So that will give us tan A. And then the other place there, plus what we've remained is sin B over cos B, which we can also write as tan B. And then divided by this portion has given us a 1. And then minus this portion, sin A over cos A will be tan A. And then this one, sin B over cos B will be tan B. So this is the identity for tan when we are adding two angles with tan. So tan A plus tan B over 1 minus tan A tan B. So that means if there was a minus here, all that would have changed is this would have become a minus and this would have become a plus in that manner. Alright. So having understood this, let me write it on top. So we are saying tan A plus B is the same as tan A plus tan B divided by 1 minus tan A tan B. So that means that if we add the A here, everything that we can see as B becomes A. So that will become tan A plus A gives us 2A. So tan 2A will become now tan A plus tan A, which will give us 2 tan A. And then divided by 1. This will be tan A times tan A, which will be tan squared A. So that becomes it. So there are different forms in which we can work with these identities, and there are a lot of them. So depending with just those basic ones which we know, and then the rest are going to follow up. Okay, let's try a problem on this. So we've been given that find the exact value. The first what we've been given here is, let's work with this, cos 510 degrees. How are we able to find the exact value for this one? So what we are going to do is we are going to come on the quadrants. We are going to see where 510 is going to fall. So if we move 360 degrees, we are going to reach here. And then we continue moving. If we reach here, it will be 360 plus 90, which gives me 450. Okay. So 450, if I come here, I add another 90. That is going to give me 540. 540 here, 450 there. So that means this 510 falls in this quadrant. So that is what we wanted to understand. So the 510 falls in this quadrant, and we first take a revolution like that, a complete one, and then we come like that. That gives us 510 degrees. Now we need to find the acute angle associated with the x-axis, that is in correspondence with the angle 510 degrees. So this is the angle associated with the x-axis. So how do we do it? How are we able to find that acute angle? So all we are going to do, remember we took first one complete revolution. So from 510, we are going to remove 360. So that is going to give us 150. So if we remove 360, it means now we've started again from this point. If we remove 360, we've started again at this point, and then the angle that we are going to take would now be 150. So this will be now 150. So from this 150, then what will be this angle? So from 180, let's remove 150. So that will be 30 degrees. So this angle here is 30 degrees. Okay. So we are going to go on. You say cos 510 is the same as cos 30 degrees. But we know our quadrant. All students take coffee. In the second quadrant, only sin is positive, cos is negative. So we are going to put the negative in front there. So that is going to give us negative. Now what is cos 30? Cos 30 is root 3 over 2. So that becomes the exact value for cos 510 degrees. Alright, let's consider another problem. So we've been given another one where it is saying cos x squared 135 degrees minus cot squared 135 degrees. So how do we find the exact value for this one? So the first thing is we need to understand, what does cosec squared mean? Of course, we already derived. If we have forgotten, I can just help us remember. We said cosec is the reciprocal of what? It's a reciprocal of sine. Okay, so that means if we square the cosec, even the sine is going to be squared. But we know the value for 1. Okay, so that gives us cos x squared x is going to be equal to sin squared x plus cos squared x. We know that 1 is equal to sin squared x plus cos squared x. So that we've just substituted. That means our cosec squared x is going to be equal to, we have got sin over sin, which will be a 1. And then cos squared x over sin squared x, which will give us cot squared x. So this is the identity. Now again we know cot. Cot is the reciprocal for tan. So cos x squared x can also be written as 1 plus 1 over tan squared x. Okay, in that manner. So I can also write this. Okay, let me just merge it. So this is going to give us 1 times that will be 1, that will be tan squared x, and then this 1 multiplied by the denominator there, that will be 1, and then divided by tan squared x. Okay, so I'll come here. So where there is cos squared 135, I can substitute tan squared 135 plus 1 divided by tan squared 135, and then minus cot squared 135. Cot is the reciprocal of tan, so I can write that as 1 over tan squared 135 degrees. So I can also, since we have got the same in the denominator, I can also write as tan squared 135 degrees, and then on top I have got tan squared plus 1 minus 1, which I will just get as tan squared 135. Now tan squared 135 over tan squared 135 will give me a 1. So that will be the exact value for that one. Okay. So really there is nothing much that has to be done. So that is how we can find for that one. There was not even a need of replacing the angles. Of course, we would have replaced the value for 135. We consider the special angle related with 135, but it wasn't necessary for that problem. Okay, let's consider another identity. We see how we are able to work it out. So we've been given an identity cot alpha plus tan alpha divided by cosec squared alpha is equal to tan alpha. So how are we able to prove this identity? Well, what we can do is, the first thing, maybe we can split, we take the left hand side, which is equal to cot alpha plus tan alpha, and then divided by cosec squared alpha. So what we can do is, we can split this into cot alpha divided by cosec squared alpha, and then plus tan alpha divided by cosec squared alpha. Well, at this point, we know that cot is the same as sin, sorry, not sin, but cos x over sin x. And then we are dividing, okay? So divided by cosec squared. Now we know that cosec is the same as 1 over sin squared x. So this can also give us cos x divided by sin x times, and then the sin is going to go on top, that will be sin squared x. So sin can go there, and then sin can go there. We're going to remain with sin, one sin. So we're going to have sin x, which has remained here, and then multiplied by cos x. So that is the one which we're going to have, sin x cos x, and then plus. Now here we have got tan x. So we've been given tan x divided by cosec squared x, which we can also say tan is the same as sine x over cos x, and then divided by cosec is the same as 1 over sin squared x. So which I can also write again as sin squared x over cos, sorry, this is not squared, this is just sin x over cos x, and then multiplied by sin squared x. So for this one, none is going to cancel. So what we are going to have is sin 3x divided by cos x, so which I can write here. So sin 3x, not divided by x, but divided by cos x. So at this point, I can add these two equations which I have. So we are saying sin x cos x plus sin power 3x over cos x. I can also say this is over 1, and then I multiply this. So that is going to give me sin x cos squared x, and then plus sin 3x, and then everything will be divided by cos x. So our aim is to reach up to tan alpha. To tan alpha. I've started using x because it's just simple. Of course, we are going to come back to alpha. Okay. So all we are going to do is we need to make sure that everything on top is going to balance up with what we want to have tan. So let's convert cos squared x. So this is sin x. We know that cos squared is the same as 1 minus sin squared x, and then plus sin to the power 3x. Sorry, there's not supposed to be a bracket there, divided by cos x. So if I multiply this, what I'm going to get is sin x minus sin 3x plus sin 3x over cos x. Notice that this and this will cancel out. Then we remain with sin x over cos x, which we can also write as what? Tan x. So hence shown. So we've simply shown that the left hand side is equal to the right hand side. So basically that is how we go with trig identities and all sorts of things. There's really nothing much to really fear, because the data we already have, and all we need to make sure that you just follow the necessary steps when you are dealing with all these. Alright, thank you so much for watching the video. In this video I'm going to end here. Stay blessed.